Good morning children. Today we are here to discuss Unit 6 Structure of Atom or Atomic Structure of 10th class. Within this particular topic, chapter, we are going to discuss about quantum numbers. What are quantum numbers? Quantum numbers can be described as it gives information about each electron in an atom described by a set of 4 quantum numbers. The electrons within an atom, for example, if I take an atom is existing in spherical shape, and having these all are nothing but what stationary orbits. Therefore, electrons are existing within this particular atom, which describes about set of 4 quantum numbers will be there. They are called as N. N is called as principal quantum number. L is called as azimuthal quantum number. ML is called as magnetic quantum number. MS is called as spin quantum number. Therefore, it gives each electron of an atom can be described by these 4 quantum numbers. What does this particular quantum numbers gives? Nothing but what? Atomic orbital. About our atomic orbital information it is going to be given. What is atomic orbital? The probability of finding the electron in a space around the nucleus. This is the nucleus is existing there. Around the space in shells, main shells as well as subshells, where there is a probability of finding an electron. Around the space of a nucleus, around an atom, around the space of nucleus, which is called as nothing but what? Atomic orbital. These quantum numbers describes about trajectory as well as momentum of electron in an atom. What is called as trajectory? A parabolic structure, how the electron is moving from here to here if I am taking there itself. Means what? A trajectory graph you can apply it or not. It indicates nothing but what? It gives trajectory as well as momentum of electron within an atom. Within an atom, the trajectory as well as momentum of electron can be identified. Not only that one, this quantum numbers gives the position as well as energy of electron in an atom. In an atom, the position as well as what we can call it there itself, energy of that particular electron existing in main shell. We can give it, that is also one more point. This is total concept about quantum numbers to some extent. Quantum numbers are nothing but what? Which describe the trajectory as well as momentum of an electron in an atom, position and energy of an electron in an atom. It gives information. To explain that one, 4 quantum numbers will be there. N represent principal quantum number, L, ML, MS, azimuthal quantum number, magnetic quantum number, spin quantum number. Individually, one after the other, we will go detailed explanation there. First one is what? N, which represent nothing but what? Principal quantum number. This principal quantum number was designated discovered by whom there? Niels Bohr. It is designated with what? Small n, which indicates integers, a positive integers. What does this particular principal quantum number gives? It gives information about size and as well as energy of main shells. As Niels Bohr discovered about circular orbits, They are called as stationary orbits or main shells also we can call it up. Therefore, he is concerning about what? Size and energy existing within that particular shells. That shells are called as nothing but what shells? Main shells we can give it up. Example, here see it up. This is an atom in the form of circular orbit. Electron is revolving around the nucleus in orbit. These orbits are called as stationary orbits or main shells. We can call it up. N is equal to 1 first shell, K shell. N is equal to 2 L shell. N is equal to 3 M shell. N is equal to 4. As well as over here N shell, and energy existing in first shell is what? E1 energy, second shell is what? E2 energy, third shell is what? E3 energy, fourth shell is called as what? E4 energy. Therefore, each orbital is designated with what? Definite energy. Therefore, size of an atom as well as energy of the particular electron orbiting in the nucleus can be easily identified by Niels Bohr. Second point is what? It gives only positive integers such as n is equal to 1, 2, 3, 4, so on. If n value is increasing gradually, see here, n is equal to 1 means only one shell is there. This is the size of the nucleus because size of an atom can be given as this one if n is equal to 1. And we know that if n is equal to 1 based upon a formula called as a 2n square, maximum number of electrons existing in an orbit. 2n square, therefore 2 electrons will be existing within the particular shell. That is, this indicates size, and it has an energy. That energy is what? Lowest the orbital which is near to the nucleus will have the lowest energy. The orbital which is far from the nucleus will have high energy there itself in it. Therefore, it has low energy. Size can be represented as this one. If I am taking n is equal to 2, this is n is equal to 2 there itself. Means what? From here to here, the size of an atom and energy existing, it will be energy existing of a little bit slightly greater than that of E1 energy. So that what happened? And if you are taking a third orbit, this is nothing but third orbit. If you are taking it up, this becomes the size of the nucleus. Similarly, fourth orbit, if you are taking, it becomes size of the nucleus. And this within this particular orbit or fourth orbit, the electrons existing, for example, here if electrons are existing, these electrons are far from the nucleus. From nucleus, these are far. But whereas in first shell, electrons are nearly closer to the nucleus. Second shell, a little bit far from the top of the nucleus. Third one, a little bit more far from the nucleus. Fourth one, much more far from the nucleus. Therefore, as n value increases, the shell size will be gradually increases. Not only that one, the electrons which are existing in those shells also will be much more far from the center of the nucleus. That particular phenomena was given by whom there? Niels Bohr, which was designated by n letter, which is called as principal quantum number. What quantum number? Principal quantum number. Therefore, shells represent. This is nothing but what? Main shell. We call it as what? Main shell. Where main shell n is equal to 1, K shell we can call it up, n is equal to 2, L shell, n is equal to 3, M shell, n is equal to 4, N shell, so on. Shells will be that existing, that is regarding principal quantum number. Coming to what? Azimuthal quantum number. This azimuthal quantum number was designated by Sommerfeld, and it was designated by one letter. That letter is called as small l letter. Discovered by Sommerfeld, designated with what letter there? Small l letter. What does this l represent? L represents nothing but what? One subshell. Depending upon the value of n, what happened? It represents one subshell. Already we have discussed clearly in both Sommerfeld atomic model. If n is equal to 1, L is equal to 0, only one subshell, that is what? Spherical, 1s. Similarly, n is equal to 2 means what? L is equal to 0, 1 means what? Two subshells are there. Therefore, L represents what it is? Subshell of the particular atom depending upon the value of n. Not only that one, this L will have integer values 1 less than that of principal quantum number. 1 less than that of what? Principal quantum number. It will be having lesser. That is, if I am taking n is equal to 1, L is equal to 0. If I am taking s orbital, 1s orbital. If n is equal to 2, L is equal to 0, 1, 1s orbital, 1p orbital. Similarly, n is equal to 3 if I am taking L is equal to 0, 1, 2, 1s orbital, 1p orbital, 1d orbital. In that particular way, 1 less than that of principal quantum number, this L value will be existing. What does this particular L value gives information? It gives information about shape of particular subshell, how the subshell is existing, how the atomic orbital is existing, whether it is existing in spherical shape, whether it is existing in double shape, double number shape, square shape, depending upon the nature of that particular one. Shape of particular subshell can be around the nucleus. Where it is around the nucleus, how that particular shape of the subshell will be existing, we can give it up. Next one is depending upon the another number of subshells. L is equal to 0, S subshell. N is equal to 1 means 0, 1. S can, if N is equal to 1 means what? P orbital. L is equal to 2 means what? D orbital. L is equal to 3 means what? F orbital. Depending upon the N value, L value 0, 1, 2, 3, S, P, D, F. S is in spherical shape, P is in double shape, D is in double shape, F is in square shape, it exists. If I am taking N is equal to 1, L value will be equal to what? N is equal to 0. It has only one subshell, that is 1s orbital will be existing. N is equal to 2 means what? N is equal to 0, 1. 0 is represented 2s orbital. Y means N. This is 1 indicates what? Main shell. 2 indicates what? Second main shell. 3 indicates what? Third main shell. 4 indicates what? Fourth main shell. For one main shell, we will have only one subshell, that is of what? 1s orbital. N is equal to 2 means what? This is second main shell, which is having value is equal to L. Therefore, L will be having 0, 1. 0 represents second shell S orbital. 1 represents second shell P orbital. Similarly, N is equal to 3 if I am taking, I have taken here the C. N is equal to 3 if I am taken, L will be having 0, 1, 2. Means what? It belongs to 3s orbital, 3p orbital, 3d orbital. This 3 indicates number of main shell. Within main shell, 3 subshells are there. Within main shell 2 subshells are there. Within main shell 1, it has one subshell, it is 1s orbital. In that particular way, shape of particular orbit can be, of subshell can be identified. If S is spherical, P means number, D means double, F means square shape, it will be existing. By this we have completed 2 quantum numbers, children. In next class we will go with what? 2 more quantum numbers, that is magnetic quantum number as well as spin quantum number, how they will be at various. Whereas your principal quantum numbers gives about size and energy of an orbit of an atom, we can give it up. Whereas azimuthal quantum number gives about what? Shape of particular subshell. This value, azimuthal quantum number, depend upon what? Principal quantum number. Thank you, children.